Hello and good day everybody. So welcome to Engineering Physics, and for today's video, we would now be having an introduction to Engineering Physics, of course. So our first module will be divided into multiple videos. So as for the succeeding videos, just wait for them to be uploaded. Okay, so for starters, to begin with, so what is to be physics? So if you would be searching for the term physics in Google, you will be seeing plenty of definitions such as this one. This definition right here by Oxford Dictionary, this definition here by Britannica.com, and this definition here by Wikipedia. So all of these definitions are true. It's just that in today's lessons, we would now be focusing on the definition of physics as the branch of science which deals with the interaction of energy and matter. So in engineering physics, we would now be focusing on the interaction of energy and matter. So another thing, guys, so when we say physics, it is also considered as the foundation science of all physical sciences. So such as your chemistry, astronomy, geology, and etc. So what is to be the meaning of foundation science? So when we say foundation, it means that it is like the founding science. So founding science of these sciences. So for example, that you would be having a certain structure for analogy. So for comparison's sake, so let's say that you would be having this building. So this building has its beam, column, and foundation. So these two rectangular drawings at the bottom part are to be the foundation of your building. So if this is now to be your foundation, your whole structure is actually standing at the foundation. So if you would be removing this foundation here, your building cannot stand in the first place. So with that, guys, if you would now be using that analogy or that comparison to this definition, all of these sciences here cannot stand if we would now be removing physics from the world. So that is to be its comparison. And also, guys, when we say physics, it is also considered as a quantitative science. So quantitative science. Okay, so from the root word quantity, so we would now be dealing with a lot of numbers here in terms of quantity. So with that being taken into consideration, physics involves a lot of mathematics. So for you to progress in this subject, ample understanding in trigonometry, algebra, geometry, and other basic mathematics subjects is required once again for you to progress in this subject. Okay, so that is physics. So what about for engineering physics? So what is to be the importance of what is now to be the importance of physics in the field of engineering? So the main goal of a certain engineer, so may that be an electrical engineer, a civil engineer, let's say a mechanical engineer, and etc. So the main goal of whatever engineer it is to improve the sustainability of life. So that may be accomplished or that may be done through the improvement of daily activities using your machines or using new innovations in electricity, and through the protection of human lives with reliable structures such as your bridges and of course your buildings, your houses, your commercial buildings, and etc. And since there are moving parts in a certain machine and there is to be certain electricity, of course, and let's say in a certain structure, it is now to be subjected with loads such as your gravity loads, your earthquake loads, and your wind loads, the principles of physics is used for engineers to formulate such system. Of course, once again, for sustainability of life. So that is basically engineering physics in a nutshell. Okay, so proceeding. So what are to be some of the basic concepts of physics? I'm pretty sure that you are already familiar with these terms right here from your senior high school subjects. So we have here your matter, your mass, your motion, and your force. For your matter, as a sort of a review, so matter is basically anything that occupies space and has weight. So basically, whatever you are looking at right now is, well, one kind of matter. So it is now subject to gravity, so subject. And also it possesses an inertia. So that is matter in a nutshell. So what about for mass? So mass is actually the amount of matter. So simple. In a certain object. So this is now to be in terms of, let's say, grams, maybe kilograms, poundal mass, and etc. Okay, so we would now be discussing about that later on. And as for your motion, this is basically the displacement of a body with reference to its initial position. Okay, so once again, your motion is to be the displacement of a body with reference to its initial position. So in Filipino, when we say motion, gumalaw. So that is to be for your motion. So what about for your force? So for its definition, force is that which that can change the condition of a certain body from rest to motion. So in Filipino, once again, kunwari nakahinto yung isang bagay or hindi gumagalaw isang bagay, para gumalaw siya, kailangan mo ng force. Kailangan mong itulak, kailangan mo ng puwersa, and etc. And yung puwersa mismo na yun, that is basically your force itself. So once again, force is that which... Okay, so there. So for example, that a certain body is to be in motion, in order for it to stop, you need, of course, force to stop it. So there. So ayan, that we have here, once again, your matter, your mass, your motion, and your force, among all things. Okay, so proceeding, so we have these branches of physics. So we have here your classical physics and your modern physics. So for your classical physics, so if you are to be studying objects that travels less than the speed of light, so kapag mas mabagal siya sa speed of light, we would now be considering it here in classical physics. And if it is now to be faster, or let's say it is now to be traveling at the speed of light, you will now be making use of modern physics. So trivia, the speed of light is approximately 299 million meters per second. Okay, so under classical physics, we have here your mechanics, your acoustics, and your thermodynamics. And under mechanics, we have here your statics, mechanics, and we also have your dynamics. So when we say statics, it is to be the branch of mechanics that deals with bodies under rest. So basically, in a nutshell, that is now to be statics. So statics is a branch of mechanics that is concerned with the analysis of force and torque, or let's say moment, acting on physical systems that do not experience any acceleration. So it is under static condition. And as for dynamics, kabaliktaran niya, in dynamics, your bodies, the bodies that you are taking into consideration here are moving. So it is not to be under static equilibrium. So in here, the acceleration is to be 0. And here, the acceleration of the body is not equal to 0. So we would now be discussing about that later on. Okay, so that is for mechanics. And as for acoustics, this is now to be the study of sound waves. And for thermodynamics, this is now to be the study of heat transfer, the change in temperature, and etc. Okay, so as for modern physics, so in our subject, or for our subject this semester, we wouldn't be discussing about modern physics any longer, and that is because I do not have the capacity to teach all of this, because I am a civil engineer, and in civil engineering, these are not covered. So we are not concerned with nuclear physics, the theory of relativity, and quantum physics. Okay, so like what I have said earlier, that physics is to be a quantitative science. So with that, guys, we would now be dealing with physical quantities. So here, guys, so we have here your basic quantities, and we also have this thing which we call derived. So derived quantities. Okay, so for your basic quantities, as per the name itself says, so basic. So for your length, so in physical quantities, you have here your length, we have here your mass, time, temperature, luminous intensity, your current, the amount of substance, and etc. So in here, guys, so we have two types of units actually. So we have here your metric units, or the SI. So this is now to be the internationally recognized. And we also have here your English units. So for your metric units, that is to now to be in terms of meters, let's say centimeters, millimeters, decimeter, decameter, micrometer, and etc. Then for mass, we have here your grams, kilograms, microgram, etc. And as for time, we have here your seconds. So for your temperature, we also have here degrees Celsius. So this is now to be degrees Celsius. And for luminous intensity, candela. For current, that is now to be amperes. And the substance, that is now to be in terms of moles. Okay, so in English units, for the length, we have here your in terms of feet, in terms of inches, etc. And for your mass, we have here your poundal mass or pounds. And for your time, same, seconds, but in temperature, we now have degrees Fahrenheit. So with that, guys, for you to progress once again in this subject, you must also memorize the conversion factors of all of this. For example, so there is now to be, let's say, 25.4 millimeters in 1 inch. So for you to convert something in inches to millimeters, what you would be doing is that, so let's add a new page here. So for example, that you have a certain 12 inches long object. So let's say if you would want, so you want to convert this in terms of meter. So the conversion factor that you have memorized is that for every 1 inch, there is actually 25.4 mm. And you know that for every 1 meter, there are 1,000 millimeters. Okay, so with that, since you already know both of this, you can actually convert this into meters by doing this procedure. So 12 inches. So what you would be doing is that you would now be multiplying it by the conversion factor. So I know this conversion factor here. So what I would be doing is that I would be multiplying this by a fraction of. So what I want to happen is that this inches here to cancel out. So inches here. And I want this to be converted to millimeters first. So millimeters. So there. So how many inches are there in millimeters? Or you may also take it the other way around. So how many millimeters are there in 1 inch? So here, there are 25.4 millimeters for every 1 inch. So there. So with that, guys, if you would now be multiplying this, inches would now cancel out. So ang matitira na lang, millimeters. So you would now be left with millimeters as your unit. However, guys, this is not to be your goal. Your goal is for you to arrive at meters. So with that, guys, so just multiply this once again by your conversion factor. And your conversion factor this time is that your millimeters should now be at the denominator side. So denominator, millimeters. And why is that the case? Just for us to cancel this unit and for us to introduce a new unit in terms of meters. Okay, so with that, guys, so how many meters in 1 millimeter? So that is now to be 0.001, I think. So it is better if I would just be writing it this way. So there are actually 1,000 millimeters for every 1 meter. Okay, so with that, guys, just multiply this using your calculator. So looking at the calculator to your left, so 12 inches times 25.4 divided by 1 times 1 divided by 1,000. Okay, so with that, our answer here is now to be equal to 0.3048 meters. So this is now to be your answer. So basically, 12 inches is equal to 0.3048 meters. So this is also equal to 1 foot. Because 12 inches is also equal to 1 foot. So please practice your conversion for you to excel in our subject. Okay, so that is one of plenty conversion factors that you should take into consideration, and let us just now proceed. So what is now to be this derived quantity? or derived quantities here. So your derived quantities is to be the combination of two or more basic quantities. So such as, let's say, your area. So your area. So if you can remember from your previous subjects that when you say area, this is now to be in terms of square meters, square inch, square feet, or feet squared. Let's say square miles, so miles squared, and etc. So in here, your area is actually the combination of length and length. So let's say if this is now to be in terms of meters and this is also in terms of meters, their answer is now to be in terms of meter squared or length squared. So that is for your area. What about for your acceleration? So for your acceleration, if you can remember the unit, that is now to be in terms of meters per second squared. So as you can see, this is now to be the combination of length and time. So it is now to be a derived quantity. So what about for force? So I will just be writing here. So for force, so that may be in terms of newtons, and your newton is actually equal to kilograms times meter per second squared. And as you can see here, it is now to be the combination of your mass, your length, and your time. And the time. Thus, derived quantity. So it is very self-explanatory that for your basic quantity, so this is now to be your units, and for your derived quantities, it is now to be the combination once again of two or more basic quantities. Okay, so in the proper expression of physical quantities, so just like this one here, so let's proceed here. So let's add a new slide here. So for you to properly indicate the quantity, what you will be doing is that you will now be writing the number. So let's say 6. And you must write the unit. Because if that is just 6, so that is just a number and it is not to be a quantity. So for your quantity or for your physical quantity, you must have your unit. So that may be in terms of, let's say, kilograms if you want this to be your mass. So let's say 7 meters. Let's say 34.87 seconds. Okay, so once again, in the proper expression of physical quantities, it should have your magnitude. So this is not to be your magnitude. And for your magnitude, it must consist of your number and your unit. So this number here signifies how large or how small the quantity is. And the unit indicates the nature and the type of quantity that you are to be describing. Okay, so moving forward, so speaking of quantities, we would be having your scalar quantity. So scalar quantity and vector quantity. Okay, so for your scalar quantity, this is just to be your quantity that does not have any direction. So let's say 5 kilograms. Let's say 8 seconds. And etc. Or let's say 15 meters per second. So there. So all of these are scalar quantities. So what about for vector quantity? So what is to be the difference of vector quantity from your scalar quantity? So for your vector quantity, the difference is that your vector quantity has directions. So for example, 15 meters per second. So 15 meters per second. So now this is just a scalar quantity since it does not have any direction. But if you would now be introducing a direction, or if you would now be assigning the direction to this scalar quantity here, it would now be a vector quantity. So let's say due north. So with that, guys, this is now to be a vector quantity since it already has direction. So let's say 8 kilonewtons. let's say 140 degrees north of west. So this is also applicable. So this is also a vector quantity, or let's say what else? 6 meters. So let's say 90 degrees. Okay, so it did not include any directionality here because this is already acceptable. Okay, so speaking of which, so let us now talk about vectors. So by the way, as for scalar quantity, ganyan lang siya, unit lang siya, and it does not have any direction. Okay, so what about for the vectors, or so for the basic concepts for vectors? So for vectors. So for your vector notation, so this is fairly simple. So what you would be doing here is that, so we have two ways actually. So the first way is by writing the nomenclature of your vector in bold. So yung bold yung kapag naka-control B, so MS Word nyo. So let's say that this is just to be your F. So if you want that to be written in bold, so mas makapal dapat. So maybe this one here. So sorry for the presentation, but of course this is now to be bold and this is now to be, well, not bold. So if your variable is now to be bold, it is now to be considered as a vector. And another way of writing the notation of your vector is just by adding an arrow on top of your non-bold letter. So kapag ganito, vector yan, pero kung ayaw nyo magsulat ng naka-bold, you can just write it like this. So yung napakasimpleng pagsulat, just add an arrow on top. Okay, so this is now to be two ways. Okay, so this is actually incomplete. So for this vector, so let's say that this is now to be equal to, let's say 16 newtons. And since this is now to be a vector, it must have direction. So due north, let's say due south. So due south. So this is now to be your magnitude. So this is now to be your magnitude. So magnitude. And this is now to be your direction. Okay, so here you can also write it as, let's say 64 meters, let's say 54 degrees south of east. So this is to be your magnitude and this is to be your direction. So let's go back here. So once again, for your scalar quantity, it only includes your magnitude. So magnitude. And as for your vector quantity, it must have the combination of your magnitude and your direction. So easy peasy, lemon squeezy. Okay, so what about for your graphical representation of a vector? So this is just to be the notation. And for the graphical representation, napaka-basic niyan. So let's say that you would be having a certain vector that is to be, let's say 15 meters going towards the east. So just draw a line going towards the east and say that this is now to be, so nakalimutan ko sinabi ko number. So let's pretend that I said 15 meters a while ago. So 15 meters. Okay, so that is how you would be graphically representing your vector. So this may be scaled. So for accuracy of work, of course, accurate scaling is a must. So let's say that this is now to be 15 meters, and let's say that your scale is now to be in terms of 1:100. It means that this line here must be measured 15 centimeters. So once again, guys, if you want this line here to represent 15 meters with a scale of 1:100, the actual length of the line that you are drawing must be drawn 15 centimeters. So please review your scaling from your engineering drawings and plans.